Right, so previously we answered up to number 2 of our shear and stress beams. Let's see. So we got up to here, and I asked you to solve for x. Right, this value of x. Can anybody give me the value of x? Has anyone solved for it? Yeah. Right. So let's solve then for the value of x. So to get x, focus on this figure. Okay. So we have two right triangles. I want to know x. We can say these are two similar right triangles since they have the same angle here and they have the same angle here. Okay. So by ratio and proportion, RNP, ratio and proportion. So let's look at this triangle first. So we're looking for x. So base over a known value. So I know this height, right? It's 320. We've already solved for that. Equals the equivalent component on your other triangle. So base. So this length is equal to, as you can see, this total length is 4 feet. This is x, therefore this is 4 minus x, right? Let's note that. 4 minus x. So equals 4 minus x all over height, which is 480. Okay, please solve for x. What's the answer? 80. No, not 80. Hmm? Nope. There you go. 1.6. Correct. John and Lau. So it's 1.6. So this is 1.6. Therefore, 4 minus 1.6 would be 2.4. Okay, so now I can sub that here. So negative 80 plus 1 half 1.6 times 320. What's the answer here? Correct, Lawrence. It's 176. Okay, so this is now 176. Therefore, continuing our shear moment diagram. So I stopped at 180. This is an area above your reference line, so it's a positive area. Therefore, I use a positive slope. And then this is 176. Therefore, let me just extend that. Okay, I'm gonna move upward until I reach 176. Something. Okay, so this point is 176. Next, from 176, I have a negative area since it's below your reference line. So my moment, this section would be, again using our equation, so let's call that moment at B. MD equals 176 plus, sorry, MD equals, oh, let's call that MF plus AV. So MF is 176 plus. Now, to make things easier, our equation is always moment plus area, right? If your area is below your shear moment diagram, that's a negative area. That's why here, 0 plus negative 1/2, 2 times 800, because that's that area here. Okay? So for this area is negative, so 176 plus negative, then area. This is another right triangle, so 1/2 base times height. So 1/2, base is 4 minus x, which is 2.4. Then height is 480. Okay. So what's the answer here? What's MD? Correct, Reynel, Agaral, and Evangelista. And John. Okay, so it's negative 400. So now, okay, from 176, area is down, or area is negative, so I go a downward slope. So remember 1 degree higher. So I didn't mention this, but this is a sloping line, so this is a parabolic line, right? That's not a straight line. However, this is a straight line. Straight line, parabolic line. Okay? And then we have another parabolic line since this is a sloping line. Downward slope since it's negative area. So until negative 400. So you go towards negative 400. Negative 400. Okay? Then next. Finally, from ND to E, I have another positive area. So I'm going to go on upward slope. Then let's compute. ME. So ME equals this previous one, MD plus AV. Okay? MD is negative 400 plus AV. A is positive area since above reference line. And this is another right triangle. So area for right triangle, 1/2 base times height. What's this base? It's 2 feet. What's this height? 400. I can already see negative 400 plus 400. That is 0. Okay. So again, this is a positive area. So I have a positive slope, parabolic slope, or parabolic line to 0. And with that 0, therefore, you have a correct shear moment diagram. So that is number 2, right? Yes. Number 2. Do you have any questions for number 2? None? So do you understand number 2? Please answer yes or no. All right, great. So that ends the area method. Let's now move on to the next topic. So we learned how to create a shear moment diagram. Now let's put that into application by talking about stresses in beams. So you have two types of stresses in beams. First is your flexural stress, next is your shear stress. So for flexural stress, you have normal stress due to bending of member. So this is an example of that. From the term itself, flexure, it's the bending stress of your beam, okay, due to a normal force. Next, your shear stress, it is developed during bending to balance uneven horizontal thrust between sections. So you have this beam. This is gonna experience shear stress because this force, okay, creates or has an equivalent parallel force to the fibers of your beam, and that creates your shear stress. Let's focus first on flexural stress. So we have the following equations. I'm not gonna derive them anymore. Just know that, and here they are. So first, moment curvature relationship states that 1 over rho equals m over ei, where rho is your radius of curvature, m is your moment, the moment that we've been getting in your shear moment diagram. E is modulus of elasticity, and I is your moment of inertia about the neutral axis. Okay, so about neutral axis is an important info there. Now, what we'll actually focus on are the following, your flexure formulas. First is sigma equals negative my over I, or just my over I, where m again is your moment, internal bending moment. Y is distance of element from neutral axis. So later on, we'll see cross sections of your beams and their neutral axis. So y is just a distance from that neutral axis along your cross section. Then to get sigma max, okay, it's mc over I. So recall y is distance from your neutral axis. Okay. So the larger the y, right, the larger your stress. So the largest y you can get is your c, which is the distance of the extreme fiber from neutral axis. So extreme fiber means the edges of the cross section. Okay, that creates the largest distance from your neutral axis. Then over I, moment of inertia. Or you can use the equation m over s, where s is I over c. As you can see, I over c, so that gets m over s. And this is just the section modulus of your cross section. So those are your equations. Here are some common shapes and their section modulus and moment of inertia. So for a rectangle, solid circle, tube, and triangle, these are your section modulus. Okay, VH squared over 6, where V is your base, H is your height. And as you can see, noted are your neutral axis. So neutral axis, height. Therefore, for this, for a rectangle, C, in this equation, your C, as you can see, is just H over 2. Okay, this is your extreme fiber. This is your extreme fiber. Distance of that from neutral axis is H over 2. Okay, or just half your height. And same thing with the others. Yeah, neutral axis are shown. Next, we're also shown your moment of inertia of a rectangle, triangle, circle, and your semicircle. So as you can see, again, denoted are the axes at which your moment of inertia are taken. Remember, our moment of inertia is taken about the neutral axis. So here, about the x neutral axis, ix, that's vh cubed over 12. About the y-axis, it's v cubed h over 12, and so on and so forth, okay? So ix just means the horizontal line, iyy is just this vertical line, right? Okay. So let's have a few examples to better understand that concept. Okay, let's start with number 1. The simply supported beam in the figure has a rectangular cross-section 120 millimeters wide and 200 millimeters high, as you can see here. 120, 200, or 100 and 100 from the neutral axis. Letter A, compute the maximum bending stress in the beam Letter B, compute the bending stress at a point on section B that is 25 millimeters below the top of the beam. Okay, so let's start with letter A, maximum bending stress. And remember, bending stress, we've already learned to be MC over I, where C is just this 100. So now I need to know what's M. So to get M, that is where your shear moment diagram is used. Okay, so I've already created the solution here, so just follow along. Right. So you have this beam there. Reactions are already given. So now I just go directly to the shear diagram. So starting from the left, shear at 0. Okay, so we start at 0. There's an upward force or reaction of 14 kilonewtons, so go upwards by 14. Next, you have a uniformly distributed load. So therefore, my line here would be a sloping line, 1 degree higher. Okay, so from 14, this is downward, so you go downward by a certain amount, which is the area of your load diagram. So 6, so this 6 is the height of your rectangle here, times this area, right? Since I want to end up here. Remember, you're mostly always stopping at supports and at points of application of force or moment. So I have an application of force here, that's why I stopped there. That's a segment. So again, 14 minus area of this, which is 6 times 2. So 14 minus 12, that's 2. Okay, that's why I ended 2. Next, I have a point load, 15 downward, so 2 minus 15. You get negative 13. And again, you have another uniformly distributed load downward, so you go downward by how much? By the area of this. So negative 13 minus 6 times 1. So that's still 6. So negative 13 minus 6, that's negative 19. Okay. And then you have a reaction here upward, which is 19. So you go up 19. Negative 19 plus 19 is 0. So you started at 0, ended at 0. Therefore, you created your shear diagram correctly. Next, which is what we're concerned with, your moment diagram. Because from this, we'll get your maximum moment to know your maximum shear stress. So again, these are supports, therefore, or simple supports, therefore, moment there are 0. So 0. Next, look up here. This is an area above your reference line. Therefore, I have a positive slope. This is a sloping line. Therefore, 1 degree higher is a parabolic line. So I'm going to draw a positively sloping parabolic line. Then how much will it increase? So I want to know this value, right? From A to D. So again, that's just the area. So from our equation, okay, so let's call this point MD. So MD is just your starting point, MA, plus area of your shear diagram. So MA is 0 plus area of shear diagram. This is a trapezoid. So base 1 plus base 2 over 2 times height. So base 1 is 14. Base 2 is 2 over 2 times height or length or width, which is 2 meters. So times 2. Solving for that, you get 16. Okay, so you go up by 16. Next, I have a negative area since it's below your reference line. So now I go downward. I use a downward parabolic slope since again this is a sloping line. Parabolic slope by how much? Again, it's moment plus area. So considering this segment, so moment at this, so which is 16, plus, this is a negative area, so negative. Then this is another trapezoid, base 1 plus base 2 over 2 times height, which is 1 meter. Solving for this, I get 0. So I end at 0. So again, start at 0, end at 0, correct shear diagram, moment diagram. So the maximum moment, therefore, is the highest point on your moment diagram. Okay, take note of that. It's the highest or lowest point on your moment diagram. Okay, so the highest or lowest value. So it's this, obviously it's 16. Therefore, maximum moment is 16. Then our unit is in kilonewton meter. So kilonewton meter. Now, remember, we're looking for shear stress, and that is MC over I. So now M is this, 16 kilonewton meter, but our dimensions are in millimeter. Okay? And I want my stress to be in MPa, so convert this to Newton millimeter. So converting kilonewton meter to Newton millimeter, you get 16 times 10 raised to 6 Newton millimeter. Okay. So no problem with M. Next, what is C? Again, C, maximum distance of neutral axis to extreme fiber. So that's just this distance, so 100. Okay, so 16 times 10 raised to 6 times 100. Next, I. How do I get I? So recall, this is a rectangle, so equation for I, as a review, is BH cubed over 12. Okay, so BH cubed over 12. So looking at the cross section, B is 120, 120. Height, total height is 100, 100, 200. So 200 cubed over 12, that's 80 times 10 raised to 6 millimeter raised to 4. So this Newton millimeter, millimeter, millimeter. Okay, your units are consistent. So just compute, you get 20 MPa. Okay, so that's letter A. Now let's move on to letter B, which is a bit different. Compute the bending stress at a point on section B. So it's this portion that is 25 millimeters below the top of the beam. So now you're not looking for maximum flexural stress at segment B. We have a certain point, 25 millimeters below the top. So let's solve for that. So again, I want to know flexural stress there. And the equation is my over I. Okay, not C anymore, since that's for maximum. So I need to know M. So therefore, in my shear moment diagram, I need to know this point. Okay, so how? Okay. So to get that point, that's the first thing we need to do. That is the area of this. Okay, so to get the area of this is another trapezoid. I just need the height of this. Okay, so let's call that VD. So now my problem is getting the height of that. So how? So get creative. Look at that drawing. Remember, we're usually getting equations from triangles. So most likely that is what I'm gonna do here. Okay. So if I draw a straight line here from this mark 2, from your D, as you can see, I get two right triangles. The smaller right triangle and this larger right triangle. And they're similar triangles, right? They're both 90 degrees and they both have the same angle here. So therefore similar triangles. So I can use ratio and proportion again to solve for a certain side. So comparing this right triangle to this right triangle, again, my goal is to get this. So by ratio and proportion, there. Let's zoom out a bit so that you can see everything. Yeah. Okay. So first, this height. So this height is this overall VB minus this height 2. That's why this is VB minus 2 over base, which is 2. Base, which is 2 minus 0.8. So 2 minus 0.8 equals the height of your larger triangle, which is this total height 14 minus this height 2. So 14 minus 2 over base, this total base, which is 2. Okay. Okay. So now that we have that, solving for BB, I'll get 9.2. Now, knowing that this height is 9.2, we can solve for this by getting the area of this, right? So getting the area of a trapezoid again, base 1 plus base 2. So base 1, 14, base 2, 9.2 over 2 times total length. Okay, this length is given to be 0.8. So that's why it's times 0.8. Solving for that, you get 9.28. And that's why I've written 9.28 here, because that's this value. All right? So now that's your n. So I got my n, right? Now what's y? Remember, y is now just the distance from your neutral axis. And that segment is 25 millimeters below the top of your beam. So drawing that, 25 millimeters from the top. So this is 25. This is 100, therefore 100 minus 25, this is 75. So this fiber is 75 meters from your neutral axis, and that's your y. Okay, again, y, distance from neutral axis, so 75. And then I is the same. You have the same cross section, so it doesn't really matter where you take your stress for I. Okay, so I is the same. It's 80 times 10 raised to 6. So 80 times 10 raised to 6. Computing for that, you get negative 8.7 MPa. So now what is this negative for? Why is there a negative in my equation? Well, that's because this negative sign denotes whether your stress is in tension or compression. Okay? So a negative stress means your stress is in compression. Your positive stress means your stress is in tension. Because look here at your beam. Okay? You've noticed if your beam bends this way, at the top, points get closer together. Okay? Meaning they're compressed. That's why at the top you get a compressive stress. Here at the bottom, they get stretched out more. That's why you have a tension stress at the bottom. Okay? And that this sign denotes whether you have compression or tension. So as you can see here, this negative sign denotes you have compressive stress. So that is number 2. Do you have any questions for number 2? None? Okay, gets? Do you understand number 2? Please answer yes, sir. Sorry, this is number 1. Okay, good. Next, let's move on to the next problem. There. The cantilever beam in the figure is composed of 2 segments with rectangular cross sections. The width of each section is 2 inches, but the depth of are different, as shown. Determine the maximum bending stress in the beam. Okay, so you don't have a uniform beam anymore. You have this 4-inch height or depth, and this beam has a 6-inch height or depth, right? So we're looking for maximum bending stress. So to get maximum bending stress, I need to know maximum moment. So to get maximum moment, shear moment diagram. So let's create another shear moment diagram. So again, I've already created a solution. Okay, so first, shear moment diagram. So as you can see, reaction at your fixed end, this is a fixed end, is not given. Okay, so for a fixed end, there is always a reaction and moment. So compute for those. So luckily, it's easy to compute for reaction since there's only one applied external load, 2,000 pounds downward, therefore reaction here is 2,000 pounds upward. Next, solving for your moment. Okay, so let's call this moment at D. So I assume that the direction of moment at D is clockwise. Okay, so clockwise positive, counterclockwise negative. Okay. So now solving for that is summation of moment at your fixed end equals 0. Okay, so let's start with this. So 2,000, rotate it above your fixed end. This is counterclockwise. So therefore, negative 2,000 times distance from the fixed end, which is 4 plus 4, 8. Okay? Next, this is clockwise, therefore plus MD equals 0. Therefore, MD is 1,600 pound-foot. Positive, therefore correct assumption, it is clockwise positive. After you have the reactions, draw your shear diagram first. So starting at 0, you have a 2,000 pound downward force, so go down by 2,000. Next, there's no other force here, so just go straight line. Then you have an upward reaction here, so go upward by 2,000. So negative 2,000 by 2,000, 0. Okay, correct shear diagram. Next, your moment diagram. So again, this is a free end. There's no moment there or applied moment, so you start at 0. Okay? You have an area that is below your reference line, therefore your slope is negative. This is a straight line, so 1 degree higher is a sloping line. Okay? Then, Since there's no applied force or moment here, it's just a consistent line from A to D. So how much? So get the area of this. Now, since we have different cross sections, okay, you create a division at the end of each cross section. So that's why I created a line here. Okay. Now shear force is the same even though we have different line moment, different height or width of your cross section. Later on, you'll see why I created this. So again, going back, I want to know this value. So that's just considering section AB. So AB, so it's just MA plus area above your shear area. So 0 plus, this is below your reference line, so negative. Then this is just a rectangle, so negative 2,000 times base, which is 4. So you get negative 8,000 pound-foot. So this is negative 8,000. Next, now you don't always have to do this to this, considering segment BD, then negative 8,000 minus area of this. Okay, you can do that, or if you don't want to, since this is a consistent area, you can start at A again up to D. So considering section ADN, so from MA, which is still 0, minus or plus negative area, and this area now is okay. So this area is rectangle, so negative 2,000 times length, which is 8. So negative 2,000 times 8, 16,000 pound-foot. All right. If you want to practice, try doing, considering this segment BD, okay, so it's M at D equals, let's call this B, moment at B, moment at D. Okay, MD equals negative 8,000 plus negative shear area of this. Okay, so you should get 16,000 as well, a negative 16,000. Okay, so try that at home if you want. Try that on your own. Well, what is the sense? Why did I do that? Well, now we know this negative 8,000 is the maximum moment between segment AB, and this 16,000 is the maximum moment between segment BD. Okay, so now at the maximum moment, I can solve for maximum stress for each segment. So you can do MC over I, where C is just half the heights of these. Or another way to solve is to get the section modulus. So the equation for section modulus, and for a rectangle is BH squared over 6. Again, you can use MC over I. Let's try doing M over S. So BH squared over 6. Okay, BH squared over 6, let's start with AB. So base is given to be and with 2. So this is 2 times height. As you can see, 4 squared over 6, you get 5.33 inch cubed since everything is in inches. Next, for section BD, again, base squared over 6. So B is 2, H is 6 squared over 6, you get 12 inch cubed. Next, sub that in your equation, shear stress of flexural stress equals M over S. Okay, so for AB, M is 8,000. This is in pound-foot. Our S is in inches. So convert feet to inches. So that's why there's a 12 here. Feet to inches. So 8,000 times 12 over S, 5.33. You get 18,000 PSI. Next, for this section, BD. Again, MBD is 16,000. Pound to inches times 12 over S of BD is 12. Answer there is 16,000 PSI. The question is, what's the maximum bending stress? Obviously, it's this, 18,000 PSI. So that's your answer. Do you have any questions for number 2? None? Okay, do you understand number 2? Please answer yes or no. Alright, great. Next. Last question for this. Number 3. The wide flange section W14 by 30 is used as a cantilever beam. So that's just how you name the section. I won't go into that anymore. It's used as a cantilever beam as shown in the figure. Find the maximum bending stress in the beam. Then section modulus of a W14 by 30 section is 42-inch cube. Okay. So again, we're looking for maximum bending stress given this figure and section modulus is 42. As usual, and what we do is create your shear moment diagram. So given S, okay, so we're gonna use M over S since S is given. So now I just need to know what's N. But before that, I need to solve for reactions. This is another cantilever beam. You have a fixed end here, so there's moment and reaction. There's only one applied force. This is a couple that doesn't affect your reaction, horizontal, vertical reactions. Okay, so just one. Negative 5,000 since downward. Therefore, reaction at this end would be upward to counter that. So reaction at D, 5,000 pounds. Next moment, okay, same thing. This is clockwise, so I'm gonna assume, okay, that the reaction here is clockwise, right? Assuming it's clockwise, again, take summation of moment at fixed end equals 0. So starting at the left side, negative 5,000 rotated about your fixed end, it's counterclockwise. So negative 5,000 times distance from your fixed end, 3 plus 3, so 6. Next, we have a couple, which is clockwise, with a value of 25,000. So clockwise, therefore, positive 25,000. Okay, so for a couple, just directly write in its value. And then MD is clockwise. My assumption is clockwise, so MD equals 0. Solving for MD, I get positive 5,000 pound-foot. Positive, therefore, my assumption is correct. It's clockwise. Therefore, this is clockwise, so positive. Okay, next step, shear moment diagram. So starting at 0, not downward force, so negative 5,000. There's no applied force, so just straight line. Upward force, 5,000. You end at 0. So correct shear. Next, moment. So start at 0 again, you have a free end, there's no moment applied there. So 0, negative area, so you go downward by this area. Okay. So moment at B, let's call that moment at B1. So MA 0 plus negative area. So negative area of this is a rectangle. So base times height 5,000 times height. Base 3 times height 5,000. You get negative 15,000 pounds. Yeah, negative 15,000. Next, you have an applied couple clockwise, therefore that's positive. In your moment diagram, that is upward. So negative 15,000 plus 25,000, you get 10,000 pounds. Okay, so just go directly upward. Next, you have another negative area, so you go downward. So compute for how much. So using the equation, again, considering segment B to D, so we have 10,000 plus negative area. So negative area of this is again 5,000 times base 3. Computing for that, you get negative 5,000. So you go down from 10,000 up to negative 5,000. And then there's a reaction here, your moment reaction, which is positive 5,000. So you just go up by 5,000. Negative 5,000 plus 5,000, 0. Start at 0 and the 0 correct moment diagram. Okay. So again, question here is what's the maximum maximum flexural stress, bending stress. So just get the highest value in your moment diagram. And that is 15,000. So therefore, M max 15,000. So using that, shear stress, bending stress equals M over S. M over S 15,000. This is pound-foot. RS is in inches, so convert again feet to inches. That's why this is times 12. S is given to be 42 over 42. Solving for that, you get 4,285.71. This is pounds per square inch, so that is PSI. Okay? That's number 3. Any questions for number 3? Okay, so do you understand number 3? Please answer yes or no. All right, good. And now moving on to the last topic for this term, shear stress. So again, there's two types of stress, right? Flexural and shear. We talked about flexural. Now let's move on to shear. So you just have this equation, shear stress equals VQ over IB. So we'll be using that. Where V is your shear, similar to your flexural stress is MC over I, M is moment. From your moment diagram, here V is shear from your shear diagram as well. Q, moment of area above or below the fiber in question about MA, neutral axis. So what does that mean? Moment of area, that means just area multiplied by distance. Okay, so AD, area by distance. Above or below fiber in question about NA. So for example, okay, my fiber in question is this. It's the fiber in question. Moment of area above or below. Now choose which is easier to get about your NA. Obviously, area above. So this is my area above. Okay. So area of that multiplied by distance of that from your neutral axis. That's your Q. So to get distance, you need to get the center of your area, which for a rectangle is easy, it's just height over 2. So it's this distance, it's this point from this point. And that's YC sub 1 or YC1. Okay, so Q is just this area times YC1. Okay, that's it. That's your Q. Next, I, moment of inertia, similar to your flexural stress. And then B, just the width of the fiber where shearing stress is desired. So for example, again, this is my fiber in question. B is just the width of that. There. Okay? Look here. This is your shear stress diagram for a cross section. So this is a beam with a fixed end. So what does this mean? It means at the edges, at the surfaces of your beam, there's zero stress, shear stress. Why? Because it's the surface. Okay? So there's no shear stress on the surface of a beam or an object in general. However, going inside your beam is going to experience shear stress now. And the maximum shear stress on a cross section of a beam is at its neutral axis. Okay? So there, if you want to get maximum shear stress, you consider the fiber at your neutral axis. Okay, next. Have an example. Before that. These are the maximum shear stress of common area or common shapes. For a rectangle, maximum shear stress is just 3V over 2A. For a circle, 4V over 3A, and so on and so forth. Let's have an example. So you have simply supported wood beam in the figure is fabricated by gluing together 3 160mm by 80mm planks as shown. Okay, so you have 1 plank, 2 plank, 3 planks, 80mm each. Calculate the maximum shear stress in glue and wood. So maximum shear stress in glue, let's start with that. Glue, the only glue here is this portion, and this portion. Okay? And if you remember, the equation for shear stress is VQ over IB. Okay? So Q is related to the distance from your neutral axis. Okay? So this glue and this glue have the same distance from your neutral axis. So I don't have to solve for both. Okay? I can just solve for one and it's going to be the same answer as the other. Okay? But in the event that this glue and this glue are not situated this way, you need to solve for each segment. Okay? This is symmetrical. That's the only reason why I can just solve for one. So let's start. Okay. So again, we're looking for shear. So I need a shear diagram. So you have this. Reactions are already given. So just write your shear diagram. So from 0, you go upward since you have an upward reaction by 24. Next, you have uniformly distributed load. So you get a sloping line downward. By how much? By the area of this. So 8 times 6, that's 48, minus 24. So yeah, equation for VB is 24 minus area of this 8 times 6, you get negative 24. So go down by negative 24. Then you have an upward force 24 kilonewtons, so go up, and you end at 0. Negative 24 plus 24 is 0. So again, correct shear diagram. So next, looking at the diagram, figure out what's your maximum shear. For this, it's easy. It's just 24. So Vmax is 24 kilonewtons. Okay, now, we use that for VQ over IB. Okay, so V is easy. Again, that's 24 kilonewton. Okay, as you can see, my dimensions are in millimeters again. So convert your kilonewton to newton so that the stress that I get is in newton per millimeter squared or MPa. So 24 times 1,000, 24,000 newtons. Next, Q. Q is just AD. A is the area above or below your fiber in question. Okay, so the fiber that I choose for glue is this section. Okay, again, this and this are the same since they're equidistant from NA. So I'm just gonna use the upper one. So this your glue, area above it is this. Okay, so how do you get that? So 80, 80, 80. Right. This is 80, this is 80, this is 80. Okay, so that's 80. Therefore, area of that is just 80 times width, which is given to be 160. Okay, so 80 times 160, no problem there. Next, what's the distance? The center of this rectangle is just this point, which is 40 by 40. So this is 40, this is 40, right? This is 40, this is 40, right? Since this whole thing is 80, therefore this height is just 40. Therefore, all in all, distance of center from neutral axis is 80. So times 80. Computing for that, Q is 1,024,000 millimeters to 4. Now I have Q. Next, I. This is a rectangle, so that's just VQ over IB. Now, considered with glue, it doesn't matter. For moment of inertia, you're still going to consider the total cross-sectional area. And the total cross-sectional area is a rectangle. So BH cubed over 12. So B is 160, total height is 80, 80, 80, that's 240. Okay, 80 times 3. Cube over 12. Computing for I, you get this. Subbing all of that into VQ over IB. Again, V is 24,000, Q is this, I is this, and B is the width of your fiber in question. My fiber in question is this, width of that is 160. So 160. Computing for that, you get 0.83 MPa. Okay, done. Next, letter B. For the wood. So again, I'm looking for maximum shear stress. Maximum shear stress for a beam is at its neutral axis. Okay? I'm gonna consider this as my fiber in question. Let's do that. And again, so this is now my fiber in question. So now I need to compute VQ over IB. V is the same. Your maximum V is 24,000. Okay. Q is AD. So now, again, A is area above or below fiber in question. My fiber in question is NA. So you can either get area of this or this. I got this. Okay, so this is 160 times height. Height of that is 120. Again, because this is 40, this is 80, so total height 120. Okay, so 120 times 160, that's your area. Next, distance of center to neutral axis. This is the center of your rectangle. Total height of that is 120. Therefore, half of that is 60. Therefore, distance of this point from neutral axis is 60. Therefore, 60. Solving for this, you get 1,152,000. Now that's your Q. And I is still the same since you're still using the same cross section, which is this. Okay. And then B, width of your fiber in question, which is 160. This, yeah. So solving for that, you get 0.94 MPa. That is number 1. Okay. Do you have any questions for number 1 for shear stress? None? Okay, so do you understand number 1, shear stress? Please answer yes or no. Okay, very good. And that ends our topic and our lecture for this term. So now, you're gonna have your final journal. Okay, remember we have 3 journals. You're done with course, expectation, and midterm assessment. Now you have your final assessment. Okay, so let me explain. So just answer the following. Number 1, what have you learned in this class? Okay, so everything that you understood, everything that stuck to you, what topics are your favorite, okay, those things. What have you learned? Or even if not necessarily about MEC32, just what you've learned in this class. Next, what do you want to improve about this class? So you've done your midterm assessment, okay? So have I done that? Was there some things I wasn't able to do? Right, that there are there things that you thought of that you want us to do? Again, put it there. For example, am I still speaking too fast? Is the pacing too fast? Yeah, those things. And then what would you like to keep in this class? We've had our quiz shows. Do you want to have that? Do you want to keep that? Do you want to keep the pacing, the speed of our lectures? You know, anything you want to keep about the class, keep that in there or write that in there. Next, what do you think about your overall performance in this class? So the only thing that's missing now is your modular exam and your project, which is due tomorrow. And then your modular exam on Saturday. So far, what do you think? Are you doing well? Do you think you could have done better? Those things right at there. Next, suggestions. Okay, what suggestions do you have? What kind of, do you have a game in mind that you would like to have? Do you have a topic in mind that you want me to discuss? Or do you want to be discussed in MEC32 for future classes? Anything under the sun right that there. And then 6 final words, just anything you want to say, since this could be the last time that we'll have a class with each other. Okay? So that's your final assessment. Deadline of this final assessment is on Saturday, 11:59 p.m. And with that, the lecture part of your term is done. So do you have any questions? So, yes.
Ma'am, paano po pag late na pasa yung quiz? Like, a minute lang po.
Okay lang. I'm gonna grade it pa rin. Okay? Hindi ko lang na-check pa yung mga late.
Sige po. Thank you po, ma'am.
Okay. Oh, any other concerns? Okay, this is your last chance.
Ma'am, tsaka paano po pa kunyari pag hindi po nakaabot sa yung IP po? ng kunyari module 3? Paano po gagawin?
So, that for module 3, if you get an IP automatic, you're gonna have to get completion for next term. Okay, so you're gonna re-enroll, not the whole term, just module 3. You're gonna complete completion activities for next term. You can resubmit your reviewers, right? But please let me know. Send me a message if you resubmitted your reviewer so that I can check them again. Okay. So yes, you can pwede kayo mag-resubmit. Reviewer 3, I think naka-unlimited attempts yun. So you can just submit and submit until you're satisfied. I'm just gonna check the latest one. Okay? Ayan, if you have 2 IP, you're automatic 5. Oh, okay. Quiz 3. Oh, I see. Sorry, I wasn't able to read that. Hey, you can retake quiz 3. But I'm gonna ask you, when can you retake quiz 3? When can you take quiz 3? Tomorrow. All right. What time? Right. So tomorrow. 1:30 to 3 tomorrow. Are you okay with that? One thirty to 3 o'clock tomorrow. Is that okay with you? Okay. So remind me 10 minutes before your exam na nakaschedule ka for 1:30. Okay? Remind me. Okay, thank you. Next, module 1 IP na ba talaga yon? Kahit naman po sa test for IP. Kahit nakapasok. Okay. So for module 1, it doesn't matter if you pass your IP modular exam, right? What you need is to get a grade or a score high enough to get a grade of 70% for your module 1. Okay, pero 70 ka na. 79 final grade mo. Okay, let me check. Let me check na lang. Okay, give me a second. Module 1. Okay, okay. Okay. Yan o, your tres na. Hindi ko lang napalitan. Okay, isa-isa, wait lang. Completed module 1 grade. That is in your full grade center and G1 parentheses for IP students. Okay? Check it now. Grade center. Katabi ng MG1. MG1 parentheses for IP students. Next. MG1 for IP. So, okay, yeah, that's stress na. Babaguhin ko. Hindi ko pa. So your M1 grade, that's the final grade, okay? So I haven't updated it yet because I have to input it manually. Okay, the latest or the most recent that I've done that was I think over the weekend. Okay, so if you've answered your exams after the weekend, I haven't updated that yet. Let me just check. Okay. Okay, so as long as you can see that for MG1, for IP students, you pass, you get a grade of 70, I'm gonna eventually change that in your M1 grade to 3 as well. Okay, so don't worry about that. Babaguhin ko pa before submission of final grades. If you've noticed on Sunday morning, okay, Sunday morning or Saturday night, that your grade has not been changed, send me a Facebook message because there could be a chance that I overlooked that. Okay, wait, isa-isa, wait lang. So for Module 1, your completion activities are your modular exam 1 retake and homework. Okay, you're just gonna re-answer your assignment number 1. Okay, for Module 2, it's only modular exam 2 retake. Okay, yun lang yung activities, tatlo. Answering modular exam 1 retake, modular exam 2 retake, and re-answering assignment number 1. What if pasado module 1 and 2, bumagsak module 3? No. You need to complete module 3 next term bago ma-credit for you to essentially pass the whole course. I think it's free to get your to complete your module 3 if ever you get an IP on that for next term. But you meron eh. Walang MG1 na nakalagay sa grade center ko. Nandyan yan. Send me a screenshot. Bakit di mo makita? Nasa tabi ng modular exam 1 retake. Bago mag-umpisa ang midterm assessment. Wala kayong project number 2. A column before your project number 2.
Ma'am?
Yes? Yes?
Paano po pala dun, ma'am? Kunyari doon sa late na quiz po. Kailan po lalabas yung score?
Mamaya. Check ko na mamaya. Gusto mo ngayon na.
Thank you po, ma'am.
Sige. Anong quiz yun?
Sa module 3 po, ma'am.
Alright. Okay. Okay. Yeah. I haven't checked quiz 3. Okay. So, mamaya. Check ko na yung quiz 3 mamaya.
Arigato, ma'am.
Okay. So, what day final exam? Saturday. 12 to 1:30. Modular exam. Ano pa? Hindi. Tayo ang mag-a-approach sa akin. From what I know, you're gonna be enrolled automatically to your completion course. Yun yung mangyayari pag IP kayo. Okay, hindi ako mag-a-approach sa inyo. Any other questions? Yes. Mga hindi retake ka. Yung mga hindi nakapag-take ng quiz 3. Okay. Okay, first of all, ito. For those who did not take quiz 3, write me an excuse letter explaining why you weren't able to take your quiz 3, signed by your guardian. Or for example, my conflict of schedule, signed by your professor na nag-conflict sa schedule. Then, exam is 1:30 to 3 tomorrow. Send me a message 10 minutes before your exam to remind me that you are gonna take your quiz 3. Okay, any other questions? Wait, wait. Um, ah, wala akong nakuhang message from you. Wala sa course center ko yung message na yun. Yeah. I mean, wala sa course messages ko yung message mo. Oh, really? Course message? Messenger. Alright. Guys, that's why. Okay, wait lang. I thought you were able to take your exam. Okay. Yes, please create a letter. Signed by your guardian. Hindi mo ako binalitaan ulit bago mag-12 eh. Kaya akala ko nakapag-exam ka. Any other, okay. Alright, no problem. Any other concerns? Yes. Right. Marami mo namang late activity. Sige, I'm gonna check yung mga late. Yeah. Well, if you're late on module 3, yep, I'm still gonna check late submissions. Later or tomorrow or Saturday, I'm gonna check all of them. Okay? So just check Saturday night or Sunday morning if there's an activity that I missed checking for you, or if I wasn't able to change your M1 grade, M2 grade, so that I can look at it immediately. Any other concerns before I dismiss you? Wala na. Okay na. Alright, since you don't have any more questions, you may go. Goodbye, class.